Hello viewers, in this video I want to show you step-by-step approach in balancing redox reaction. And of course, this is a question, is an example, a very good example that we are going to use to balance redox reaction. I want you to follow me very carefully because this has been a challenge, in secondary level chemistry. And today, if you follow to the end, I assure you, you are going to not just learn the method, the techniques, but to understand it in terms of any aspect at all. So I need you to follow me, get your pen and paper, your jotter, and then be attentive and, of course, you write down. Alright, so the question says write a well-balanced redox reaction between H2C2O4 and KMnO4. This is oxalic acid. It can also be called ethanoic acid. And of course, this is potassium, tetraoxomanganate 7. Alright, commonly used as what? As oxidizing agent. Alright, so we want to look at how to write a balanced redox reaction for these two. Alright, so firstly, we'll write for our ethanoic acid. This is our ethanoic acid. If you ionize this, it's going to form, H plus what? Plus C2O4 2 minus. And for our KMnO4, if you dissociate it, you are going to have K plus what? NO4 minus. Yes. Good. So in this situation, you will notice that we have our hydrogen ion, we have our potassium ion. Know that these two here are not our concern. These two here are not our concern. In some questions, they would give a full reaction. Do you understand? So in that case, you now get to use oxidation number method to determine your oxidation reaction and your reduction reaction. But in this case, we are not giving a full reaction. So we are just giving these two compounds. And from there, we are going to determine our oxidation and we are going to determine our reduction. And this is our first step where you ionize your compound to form this and to form this. Now, like I said, this hydrogen ion and potassium ion are not your concern. Our concern is these two here. Do you understand? These two here. So if we are going to write the full equation for this, we have, that is starting from this, we have C2O4 2 minus. If you dissociate it, you're going to have CO2. But because we have 2 carbon here, we are going to have 2 carbon here. Alright. Then the second one is this. Usually, this manganese 4, that is tetraoxomanganate 6 ion. Of course, this compound is going to be reduced to give us manganese ion. This manganese 2 ion. So it's going to give us this compound. Now, if you look at the oxidation number of carbon here, oxygen here, carbon here, oxygen here, we'll be able to determine if this one is our oxidation reaction or this. Do you understand? So if we should look for the oxidation number of carbon here, so if you are looking for oxidation number of carbon, we'll represent this carbon as X. So remember, we have 2 atoms of carbon here, so we have 2X. Are we together? So we have 2X plus oxygen is minus 2 generally, the valency. So the oxidation number of oxygen is minus 2 except in peroxide. Alright, so times 4 because there are 4 atoms here. Are we together? But because this compound here, this ion here has an ion here, so we equate everything to this minus 2. So minus 2. So 2x plus Minus 2 times 4, that is minus 8. Minus 8 equals to minus 2. So 2x equals to, if this 8 crosses over, it becomes plus. Minus 2 plus 8. 2x equals to what? 2x equals to 6. That is, divide both sides by 2. We have x equals to plus 3. So my carbon here has an oxidation of what? Plus 3. How about my oxygen here? Minus 2. Now let's look for the oxidation number of carbon in this case. So if it decreases or it increases. So we have x plus, oxygen is minus 2 as you know. That is minus 2 times 2 equals to 0. Because this does not have a charge on it, so we equate it to 0. So x 2 times minus 2 times 2 minus 4 equals to 0. So x equals to, the 4 crosses to the other side. We have plus 4. So here my carbon is what? Is plus 4. Are we together now? Alright. Now some person will be asking, why is it that we did not use these two? Now this is a mole. This is a mole of carbon 4 oxide. It does not contribute, does not necessarily contribute to when we are looking for oxidation number. Are we together? Now, but if, for instance, now you can see that there is a what do they call it? A subscript here of 2. This one is the number of atoms of this carbon atom. Is different from these two. These two is serving as the mole, the number of mole of what? Carbon 4 oxide. Are we clear now? So now, remember that one of the definition of oxidation is increase in oxidation number. And if you look at this carbon, it increases from plus 3 to what? To plus 4. This tells me that this reaction, this first reaction is my what? Is my oxidation reaction. That is oxidation. Are we together now? Now let's look for the oxidation number of manganese in this case. So we are looking for manganese, so we represent it as x plus into bracket. Remember, oxygen is usually minus 2, right? So minus 2 times how many atoms of oxygen do we have? 4, right? So times 4 equals to, this is an ion, so we equate everything here to what? Minus 1. So x, if we open this bracket, minus 2 times 4, we have minus 8 equals to minus 1. Then this minus 8 crosses over, we have x equals to minus 1 plus what? Plus 8. So x equals to what? Plus 7. So oxidation number of manganese here is plus 7. Are we together? Now, here, when we have a single element or an atom having a charge, the oxidation number of that particular element, of that particular ion, is equal to the charge on it. So manganese here is what? Is plus 2. So for this now, do we say that it increases or it decreases? Of course, we can see plus, that is from plus 7 to plus 2. It's what? It actually decreases. And reduction is what? Is decrease in oxidation number. So here we have our what? Reduction. So with this now, we've gotten our what? Our half, we've gotten our half redox reaction. But we are not going to stop here. This is just the beginning. Do you understand? This is just the beginning of balancing redox reaction. Alright, please give me a second and let me confirm the record of this video. Alright, you are welcome back, guys. So from here we are going to take off from here. Is that clear? Alright. Now, if you notice, if you look carefully, we have carbon here, we have oxygen here. At my right hand side, we have carbon, we have oxygen. This reaction is what? Is balanced, because how many carbon do I have at my left hand side? I have 2. The same is for my product. How many atoms of oxygen do I have at my left hand side? That is 4, right? And here too, I have what? 4. 2 times 2, that is 4, isn't it? But if you look at the second reaction, our redox reaction, you will notice that manganese is 1 and manganese is 1, isn't it? The atoms of the, how many atoms of manganese is here? Is 1. How many atom is 1? This is a charge, this is ion, so it does not count for the atom of manganese. Is that clear? So now we have oxygen, 4 atoms of oxygen at my reactant side. But we do not have what? We do not have oxygen at my my product side. So hence, I will what? I will balance this atom of oxygen by the addition of water. Are we together? So if oxygen is here, I will have to add water here to balance the number of atoms of oxygen at my left hand side. Are we together? So let me be ruling it so that at least it will not confuse you. So from here, I'm going to pick, okay, let me rewrite this. 2 C2O4 2 minus plus 2 CO2. Are we together? Of course, it's still my what? Oxidation. Now for the second one, I have MnO4. Or please guys, if in any reaction, if had it been this one, there is no balanced number of atoms here, I will also balance it. If I have oxygen here and do not have oxygen, I will have to balance the oxygen, that's this oxygen, by adding water there. But because this is already balanced, so I balance this. Are we together? So let's continue. So to have Mn2 plus what? H2O. Do you see that now? So we've introduced what? Oxygen. Now, how many atoms of oxygen do I have here? I have 4. So because of that, I'm going to add 4 here. 4 oxygen. Is that clear? Now, but if you notice, balancing my number of my atoms of oxygen made me introduce another element here, which is hydrogen. So because of that, I'm going to what? I'm going to balance my reactant side by adding hydrogen ion. Is that clear? By adding hydrogen ion. And because I am balancing by the addition of hydrogen ion, I call this type of balancing acidic medium. This is done under what? Acidic medium, because I am balancing my hydrogen ion by adding my hydrogen atom by adding what? Hydrogen ion. So it is what? It is in acidic medium. In basic medium, instead of balancing with hydrogen, I balance with hydroxyl ion. Is that clear? That is basic condition. The third one we usually have, which is most common, is the neutral condition, where you neither add a hydrogen ion nor hydroxyl ion. Is that clear? But because this is acidic medium, I'm gonna add hydrogen ion at my left hand side. Are we together? To balance the one at my right hand side. So I have C2O4 2 minus 2CO2 oxidation. Now for my reduction, I have this plus how many hydrogen atoms do I have here? 4 times 2 is what? Is 8. So I have plus 8H plus. Do you understand now? To form Mn2 plus 4H2O, which is my what? My reduction. Please follow me carefully. Follow me carefully. This is actually, simple something if you actually follow it step by step. Is that clear now? So the first step usually is to what? Is to balance the atoms. Do you understand? So you balance the atoms. Are we together? So for the oxidation reaction is already balanced. Number of atoms are balanced. So that is why I am balancing the one for what? For my reduction. Now, the same thing here. Now you will notice that I kept repeating my both oxidation and reduction, because if you decide to keep one, you will not know the last one you worked with. So the two has to go hand in hand. Are we together? The two has to go hand in hand. This one is already balanced. So, but I kept writing it so that I know that, okay, the next step now, I'm going to work with these two. Do you understand? The next step, I'm going to work with this. So the two goes hand in hand, because you don't balance one and leave the other. Are we together now? Good. All right. So I'm going to clean this place here. I'm going to clean here. Now, Since I've balanced my, this is the question, since I've balanced my atoms now, the next thing I'm going to balance now is to balance my what? My charge. Balance the charge. Yes. So balance the what? Balance the charges. So here I have -2. This is the charge. This -2. Okay. This place is neutral because there's no ion here. Alright. So this is -1 here. This is this 8 here plus 8. Do you understand? This is +2. This place does not have any ion, so it's 0 here. Do you understand? So I will start with the first one now. I'll start with the first one, which is C2O4 2 minus to form 2CO2. Are we together? So this place is what? Has -2 because of this -2 here. 2 minus here. So but this place is 0. Are we together? So to balance this electron here at my right hand side, that's the reactant side. To balance this electron, I'm going to add 2 electrons at my right hand side. Are we together? I'm going to add 2 electrons at where? My right hand side, the product side. Are we together? So I have plus 2e minus. So I have 2 electrons here. I have 2 electrons here. Are we together? So I've balanced for my what? Oxidation. Now the second one now for the reduction, I have my MnO4 minus plus 8H plus to give me Mn2 plus 4H2O, which is my reduction. Okay, so let me clean here to avoid confusing you. It's a long process, but when you know it, you just be playing around it. You understand? Alright, so how many electrons do I have here? I have -1. This okay, now this is where this mole here is considered. Do you understand? So here I can't write just +1. No, because there is 8 mole of hydrogen here. It's also taken to be what? To be 8 ion. That is, this hydrogen has lost 8 ion. That is 8 hydrogen ion. Do you understand now? So I have 8 here. Now here, how many do I have? +2. This place is what? Is 0. So -1 plus 8, that gives me +7. Isn't it? At my reactant side, I have +7. At my product side, I have just +2. Is that clear? So to balance it such that they both have the same number of what? Of charge. That means I will add 5 electrons to my reactant side. If I add 5 electrons, that is -5 plus, that is +7. It will give me +2, isn't it? So you see that it's equal to this one. Is that clear? You see that now? You see the technique? So you are going to add now you notice that here I have a higher number of what? Of charge here. So where you have higher number of charge is where you will add electron. You understand? Where you have higher number of charge, that is where you will add electron. This place I already have electron here. I do not have any electron here. That is why I added my electron at my product side here. Do you understand? So you need to be very careful in dealing with this kind of work. In dealing in this. Do you understand? So, and one other thing you should note is that you should make sure that while adding electron, both electrons should not be at the product side or both of them at the reactant side. No. Your oxidation, if you are adding electron to your oxidation, to the product side of your oxidation, in your reduction side, you should be adding it to your reactant. What did I say? If you are adding electron for your oxidation, that is for your oxidation, if you added electron at the product side, you should add electron to the reactant side for your reduction. So both of them should not be product, should not be at the product side. Do you understand? Because later on, you are going to what? You are going to cancel them out. Are we together? Alright, so follow me to understand what I mean. So here I have +7. So I'm going to add 5 electrons here to reduce this +7 to +2 in order to balance with this one. So here I have +7. So minus 1 plus 8 to give me what? To give me plus 7. So to balance that, I have C2O42 minus to give me 2CO2 plus 2E minus, which is my what? Oxidation. Then here I have MnO4 minus plus 8H plus, I'm going to add electron here, plus 5 electron. You see that now? To give me what? Mn2 plus 4H2O, which is my what? My reduction. My reduction. You see that now? So because electron is here now, it has reduced my charge from plus 7 to what? To plus 2. You understand now? Alright. So now the next thing, since we balanced our charge, the next thing is to equalize our what? Our electron. Is to equalize our electron. That is balance the what? The electrons. Balance the electron. Now, how do we balance the electron? If you look at my oxidation reaction, you will notice that I have 2 electrons here, right? Now look at my reduction. I have what? 5 electrons. So we balance it, we make them equal, such that I have the same electron at my oxidation reaction. I have the same electron at my what? At my reduction reaction. Do you understand? So to do that, I will multiply this 5. I will multiply everything. This oxidation reaction, I will multiply everything by what? By 5. Then this reduction, I will multiply everything by these 2. You get the point now? Alright. So I have 5. I'm multiplying this by 5. So C2O42 minus to form 5 times 2 is 10. CO2 plus 5 times 2 is what? 10 electron. My what? Oxidation. Then here, this reduction, I'll multiply everything by what? By 2. So I have 2 MnO4 minus plus 2 times 8 is what? 16H plus 2 times 5 is what? Is 10E minus to give me 2 times that is 2Mn2 plus 4 times 2 is 8 H2O. This is my what? Reduction. This is my reduction. So you see that we successfully balanced the electron now. How many electrons do I have here? 10 electrons. How many electrons do I have here? 10 electrons. You see that now? Alright. So now the next thing you will do here is to now add the 2 reactions together. You will add the 2 reactions together. Some person will be like, is it just one question that we've been solving since? Yes, it's one question we've been solving since. Do you understand? So I decided to take it step by step for you to understand it. You get it now? So it's very simple. Once you follow it gently, it's very simple. Alright. So to add the 2 reactions, I have, and aside adding the 2 reactions, that is, you can cancel directly. Do you understand? Cancel the electron out so that you have a lesser reaction. Is it clear? But you can decide to add the 2 reactions. Now let me show you how to add the 2 reactions. Now this 5 here, this you start with the oxidation. We have 5 C2O42 minus. Now there is nothing here any longer, so you add it to this one. Everything at the reactant side. So you are adding reactant to reactant equals to, that is the arrow from to product plus the product. You understand? So the reactant of my oxidation plus the reactant of my reduction to have 2MnO4 minus plus 16H plus 10E minus. Now I stopped here. Now to give me, I'll come back to my oxidation, my product side now. 10CO2 plus, now this is electron. I'll bring it last because I'm particular about the compound first. So 10CO2 plus 2Mn2 plus 8H2O plus what? My 10 electron plus 10 E minus. Do you understand? So we've added them together. So my electron here cancel out. This cancel out. Are we together? So I now have a lesser. So I have 5C2O4 2 minus plus 2MnO4 minus plus 16H plus to give me 10CO2 plus 2Mn2 plus 8H2O. This is now my what? Balanced equation. Now, how do I know? Now, let's look at it, because at the end, you should be able to what? You should be able to check it. You should be able to confirm if it is actually balanced or not. Alright, so to balance it, you count the number of atoms that is of each of the reaction. Now, carbon here has 2 here. 2 times 5 is 10, right? So check it here. We have 10 carbon, isn't it? Alright, so let's move to oxygen. Oxygen, 4 times 5, that is 20, right? 20. But we have oxygen here also. So 4 times 2, that is 8. 20 plus 8, 28. Good. So let's move to our product side. Oxygen here, 2 times 10, that is 20. Look at this place. Oxygen has 8. So 20 plus 8 of oxygen, that is 28. You see that now? They are both balanced. How about manganese? Manganese, I have 2 manganese here. Go to your product side. 2 manganese. You see that is balanced? Yeah. So how about hydrogen? Hydrogen is 16 here. Look at my product side. 8 times 2, 16. Magic, right? Yeah, but not magic. Of course, if you follow to this one, you should know that these are not magic. It's understanding the concept. Take it step by step. Is that clear? Alright. So now we've balanced, we've seen that the atoms are balanced. Now how about the charge? You don't just check the atom and then you say that everything is balanced. No, I'm not check for the charge. No. I have to check for the charge. Alright, so let's check for the charge. We have 5 times 2 here. So that is what? Minus 10. Right? Good. And we have 2 here as well. 2 plus, that is, we have minus 2 also. How many do we have here? Plus what? Plus 16 here. Alright, so if you add it together, minus 10 minus 2, that is what? Minus 12. Minus 12. And minus 12 plus 16, that is plus 4. Isn't it? Plus 4. So plus 4 is my total net, is my net charge for my reactant. Now let me check for the one. Now you see, because this one is already 0 because it doesn't carry charge. It doesn't carry charge. So the one that has charge is what? Plus 4. These 2 times these 2 plus 4. You see that both my right hand side and my left hand side, they are both, number of charges. So you see that this is a balanced redox reaction. So we've been able to successfully write a well-balanced redox reaction between what? Between ethanedioric acid and what? And potassium tetraoxomanganese what? Manganese 7. Alright, so I need you to subscribe to my YouTube channel, Edusam Academy, because I'll be dropping other questions pertaining to redox reaction. Are we together now? So I'll be dropping questions on how to calculate oxidation number. If maybe while I was from the beginning of this question, if you had challenges on how I, did some check-ins on the oxidation number of manganese, of carbon, of all those stuff, I'll be uploading videos on oxidation number, and I'll also be uploading video on oxidizing and reducing agent. They can give you a reaction and now ask you which of the components compound is what is acting as an oxidizing agent or is acting as an reducing agent and all of that. So I'm going to drop more videos to give you full understanding of what? Of redox reaction. And of course, I'm still gonna solve more questions relating to balancing redox reaction. You see why you need to subscribe to my channel. And not just subscribe, turn on the notification bell to be updated on my weekly video. And not just that, in that comment section, Tell us the subject or the topic that you find challenging, and Edusam Academy is going to dismantle it for you. Do you understand? And lastly, don't keep this video to yourself. Send it to your friends and your loved ones. And I believe that you're subscribing to this channel, you're gonna enjoy it. Thank you for following to this time. You are welcome to Edusam Academy. See you in the next video.